Welcome to the constant multiple rule for derivatives. This is part 3 in my derivative rules series that's going to help you learn how to knock out derivatives. All right, let's dive right into this very simple rule that's actually going to be very widely used in conjunction with many other rules. All right, the constant multiple rule says this. If f of x is a differentiable function and c is a real number, then the derivative with respect to x of c times a function is simply equal to c times the derivative of that function, f prime of x. So the constant multiple rule says this. If you have a constant being multiplied out in front of your function, just leave it there. Just leave it there. Don't do anything with it. Just leave it there. Find the derivative of your function, and then just make sure you multiply your derivative by that c as well. So the constant multiple rule says, listen, if you got a constant out in front of your function, it stays there even after you have turned your function into the derivative. That's essentially it. Now, when we use it, it's actually going to be far simpler, to be quite honest. So in really simple terms, if a constant c is being multiplied by a function, find the derivative of that function and then multiply the derivative by the constant c at the end. But let's see how this rule is actually going to work in tandem with some of the other rules we've learned so far, including, and mostly including, the power rule. All right, so here is our first example. So we have a function 7 times x squared. So this is a constant 7 times the function x squared. So what the derivative rule says this. Find the derivative of your function. Now, we need to use the power rule for this, so hopefully you've watched the video on the power rule. The 2 falls down in front. My new power is 1 less than my old power, which is 2 minus 1. Now, what do you do with the constant of 7? Well, the constant multiple rule says it just stays out in front. You just multiply your derivative by that 7. The 7 doesn't go anywhere. So essentially, the 7 and the 2 then multiply to make a 14, and my new power is a 1, which I don't really need to write. You can write it or not write it, doesn't really matter. So the derivative with respect to x of 7x squared is 14x. It's that easy. Find the derivative of your function. If there's a constant out in front, leave it there and just multiply it at the end. All right, let's try this one on. All right, so first off, I do have a constant. I have 6 times the function, the square root of x. But I'd really like to use the power rule, but I need a power function. Have no fear. I could write the square root of x as x to the 1/2. So I have a constant of 6 multiplied by x to the 1/2, which is the same thing as the square root. So when I go ahead to find the derivative, f prime of x, the first thing I'm going to do is find the derivative of my function. The 1/2 falls down in front as my new coefficient, x raised to the 1/2 minus 1. And they say, well, what do I do with that 6? Just multiply it out in front. That's what the constant multiple rule says. It just kind of hangs out there. Don't do anything with it. Now I can kind of clean things up. Now that the 1/2 is there as well, 6 times 1/2 is 3. X raised to the negative 1/2 is my new power. Don't like negative exponents as a final answer. It's kind of like using bad grammar in English class. So the 3 is going to stay put in the numerator, but the x is going to move to the denominator where it could be a 1/2 power. That's a beautiful answer, but since we all know 1/2 power is the same thing as the square roots, we can even do that. So the derivative with respect to x of 6 times the square root of x is 3 over the square root of x. Nice and simple. All right, here's another one. Let's try this one on for size. We have 5 times 1 over x cubed. Oh man, I really want to find the derivative of this function, but I need it to be a power function. Well, no worries. We can move that 3 to the top where it could be a negative 3. Now you might say, well, wait a minute, I thought you don't like negative exponents. I don't, but I'm using them to make this a power function, so I could therefore use the power rule. All right, so here I go to find g prime, the derivative. The negative is going to fall down as my new coefficient times x raised to the negative 4. Notice how I did that math in my head. You guys are pretty smart. My original power was negative 3. Minus 1 is negative 4. You guys can start cutting corners. Now, what do I do with this multiple out in front of 5? Leave it there. Just make sure you multiply by it. So the 5 times the other coefficient that now is there because of the power rule is negative 3. Those multiply to get negative 15, x to the negative 4. Once again, don't like negative exponents in my final answer, so the negative 15 is going to stay put, and the x to the power of 4 is going to move to the bottom. So the derivative with respect to x of 5 over x cubed is equal to negative 15 over x to the 4th. Wow, is that way easier than using the definition rule with limits to find derivatives. All right, here's another one. Now, this is where we got to be really careful and really smart considering our algebra skills. First, I have a constant of 4/3 times 1 over x squared. I just kind of pulled these apart, right? Like, you do not need a common denominator to multiply. So you can multiply 4 times 1 is the 4, 3 times x squared is the 3x squared in the denominator. But now I could have my constant of 4/3 hanging out in front, and I could rewrite that as x to the negative 2. That way it's a power function. Now I can start my process to find y prime, the derivative. So the 4/3 is a constant that just kind of hangs out for a second. Negative 2 comes down as my new coefficient, but I already had that 4/3 there, so they're going to multiply. And it's x to the negative 3. Again, my old power was negative 2 minus 1. I can do that math in my head. Negative 2 minus 1 is negative 3. So the 4/3 and the negative 2 multiply to become negative 8/3 x to the negative 3. Don't like negative exponents in the final answer, so we're going to have the negative 8 over 3. And now the x is going to go to the denominator to join the 3, where it can have that positive 3 power. So the derivative with respect to x of 4 over 3x squared is equal to negative 8 over 3x cubed. Pretty easy rule. All right, here's another one that initially looks a little bit weird, a little bit funky, but let's take our time with this, because I actually need to do a little bit of algebra first. That way I could utilize my derivative rules. So first thing I'm going to do, because I see those parentheses there, is I'm going to actually square it. Now, because parentheses, everything gets inside gets squared. 3x times 3x, that's going to be 9x squared. Then I'm going to peel apart the 4/9 from the 1 over x squared. So 4/9 is simply my constant multiple out in front. And then I'm going to write that x to the negative 2. That way I can apply the power rule. So all of that had nothing to do with derivatives. That was just turning it into a power function so that I could apply the derivative rules. So 4/9 is the constant multiple that just sits there, multiplied by the negative 2 that falls down in front using the power rule, x to the negative 3. Negative 2 minus 1 is my new power of negative 3. So I get negative 8/9 when the 4/9 and the negative 2 multiply, times x to the negative 3. Don't like negative exponents, so guess what? The x is going to go to the denominator with a positive 3 to join the 9. So the derivative with respect to x of my original function, 4 over 3x squared, equals negative 8 over 9x cubed. There is my derivative. All right, one more problem coming at you here. It's a really good one as well. So once again, got to use a little bit of algebra skills. I have a 7/2 as like a constant multiplier times x to the 3rd. Or again, you could do 7/2 and then the x moves to the top where it's a positive 3. Again, negative can move to the top as a positive, vice versa. You get the idea. So now I'm going to actually apply a couple rules at once here. The 7/2 is just a constant. It just stays there, right? The 3 falls down in front from the power rule, x to the 2. My old power was 3. 3 minus 1 is 2. The 3, my new coefficient, is going to join the 7/2. They're going to multiply together to get 21/2 x squared. Leave it just like that. Again, that's beautiful. Don't have a negative exponent, so no need to change anything. The only thing I could do is I could put the x squared on the side or the top. It doesn't really matter. Just don't put it on the bottom because, again, it doesn't have a negative exponent, so it doesn't need to move to the bottom. So the derivative with respect to x of my function 7 over 2x to the negative 3 is equal to 21x squared over 2. Nice, easy derivative rule. So the constant rule is a really simple rule that oftentimes just kind of goes in unison with some of the other rules that we're going to use. You know, the power rule is a very widely used rule, but the constant multiplier rule might even be more used because anytime you got a constant out in front, you just kind of leave it hanging around there, no big deal. All right, that's it for the constant multiplier rule. Hopefully derivatives are getting really easy. Don't forget to like and subscribe, please. See you later.